Welcome to the Introduction to Web Services, Part 1 of the SoapUI training syllabus. Now before you continue, you should have a basic understanding of the following two languages: HTML, Hypertext Markup Language, XML, Extensible Markup Language. Now I highly recommend you cover the latter subjects first before you continue with this course. So if any of those were unfamiliar to you, step away from the screen. If they are, continue with the course and enjoy it. So web services in a nutshell. Web services are application components. Web services communicate using protocols, and they are self-contained and self-describing. Web services can be discovered using UDDI, and web services can be used by other applications. And of course, XML is the basis for web services. Now, what is a web service exactly? A web service is a standards-based, language-agnostic software entity that accepts specially formatted requests from other software entities on remote machines via vendor and transport-neutral communication protocols, producing application-specific responses. So let's take a look at some platforms and elements. The basic web services platform is XML combined with Hypertext Transfer Protocol. XML provides a language which can be used between different platforms and programming languages and still express complex messages and functions. The Hypertext Transfer Protocol is the most used internet protocol. If you're familiar with websites and HTML, this of course will be important to you as well. Web Services platform elements consist of SOAP, Simple Object Access Protocol, UDDI, Universal Description Discovery and Integration, and WSDL, Web Services Description Language. So how does a web service work? We need to have a basic understanding of how web services work. For quite a while now, there has been a lot of buzz about web services, and many companies have begun to rely on them for their enterprise applications. So what exactly are web services? To put it quite simple, they are yet another distributed computing technology like Corba, RMI, EJB, and many more. They allow us to create client-server applications, in short. For example, let's suppose I keep a database with up-to-date information about weather in the United States, and I want to distribute that information to anyone in the world at any time. To do so, I could publish the weather information through a web service that, given a zip code, will provide the weather information for that specific zip code. The clients, and the clients refer to programs that want to access the weather information, would then contact the web service in the server and send a service request asking for the weather information. The server would return the forecast through a service response. To give such a basic and sketchy example, well, let's use weather for now, but basically it's a request that receives a response using a web service. Now be careful, web services are not websites. Don't mistake this with publishing something on a website. Information on a website is intended for humans. Information which is available through a web service will always be accessed by software, never directly by a human, despite the fact that you as a human might be using that software. Even though web services rely heavily on existing web technologies, such as Hypertext Transfer Protocol, they have no relation to web browsers or HTML. So repeat after me: websites are for humans and web services for software. So let's take a look at the benefits for web services. Web services are platform independent and language independent since they use standard XML languages. This means that my client program can be programmed in C# or C++ and running under Windows, while the web service is programmed in Java and running under Linux. Most web services use Hypertext Transfer Protocol for transmitting messages. This is a major advantage if you want to build an internet-scale application, since most of the internet's proxies and firewalls won't mess with the Hypertext Transfer Protocol traffic, unlike Corba, which usually has trouble with firewalls. Then, loosely coupled, each service exists independently of the other service that make up the application. Individual pieces of the application to be modified without impacting unrelated areas. While technologies such as Corba and EJB are geared towards highly coupled distributed systems, where the client and the server are very dependent on each other, web services are more adequate for loosely coupled systems, where the client might have no prior knowledge of the web service until it actually invokes it. Highly coupled systems are ideal for intranet applications, but perform poorly on an internet scale. Web services, however, are better suited to meet the demands of an internet-wide application, such as grid-oriented applications. Then we have ease of integration. Data is isolated between applications, creating silos. Web services act as a glue between these and enable easier communications within and across organizations. Services reuse. This takes code reuse a step further to another level. A specific function within the domain is only ever coded once and used over and over again by consuming applications. Now, with every good thing comes a bit of bad. So let's take a look at the disadvantages. Overhead. Transmitting all your data in XML is obviously not as efficient as using a proprietary binary code. What you win in portability, you lose in efficiency. Even so, this overhead is usually acceptable for most applications, but you will probably never find a critical real-time application that uses web services. Lack of versatility. Currently, web services are not very versatile, since they only allow for some basic forms of service invocation. Core-Buff, for example, offers programmers a lot of supporting services, such as persistency, notifications, lifecycle management, and transactions, for instance. Let's take a look at all the steps involved in a complete web service invocation. For now, don't worry about all the acronyms like SOAP and WSDL. They'll be explained soon enough. So, first of all, a client may have no knowledge of what web service it is going to invoke. So our first step will be to discover a web service that meets our requirements. So find one. For example, we might be interested in locating a public web service which can give me the weather forecast, if we have to use that one again, in US cities. We'll do this by contacting a discovery service, which is itself a web service. Then the discovery service will reply, telling us what service can provide us the service we require. Then, of course, we know the location of the web service, finally, but we have no idea of how to actually invoke it. Sure, we know it can give me the forecast of a US city, but how do we perform the actual service invocation? We have to ask the web service to describe itself, tell us how exactly we should invoke it. Now, the web service replies in a language called WSDL, Web Services Description Language. It's all in the name. Then finally, we know where the web service is located and how to invoke it. The invocation itself is done in a language called SOAP, S-O-A-P, Simple Object Access Protocol. Therefore, we will send a SOAP request asking for the weather forecast of a certain city. And then, of course, the web service will kindly reply with a SOAP response, which includes the forecast we asked for, or maybe even an error message if our SOAP request was incorrect. So to cover WSDL a little bit more clear, it's a document that contains a document that is a set of definitions with a single root element. Services can be defined using the following XML elements. Types, what data types will be transmitted. Messages, what messages will be transmitted. Port type, what operations will be supported. Bindings, how will the messages be transmitted over the wire. Port, what's the physical address of the service, and service, where is the service located? Now, to put it even more simple, think of types as data type. Think of messages as a method. Think of port type as an interface. Bindings as an encoding scheme. Port as a URL, and service as many URLs that we have to search to find a specific service. So let's take a look at the web services architecture. So what exactly are SOAP and WSDL? They are essential parts of the web services architecture. So in the architecture, we have the following listed. Processes, which can refer to discovery and choreography. Description, which is the WSDL, the Web Services Description Language. Invocation, the most popular invocation protocol is SOAP, but we could, in theory, use other protocols. And then, of course, transport. The most popular transport protocol is Hypertext Transfer Protocol, but we could, in theory, use other protocols. So let's take a look at service processes. This part of the architecture generally involves more than one web service. For example, discovery belongs in this part of the architecture since it allows us to locate one particular service from among a collection of web services. Then the service description. One of the most interesting features of web services is that they are self-describing. This means that once you've located a web service, you can ask it to describe itself. and tell you what operations it supports and how to invoke it. This is handled by the Web Services Description Language, WSDL. Service invocation. Invoking a web service, and in general any kind of distributed service such as a CORBA, object, or an enterprise Java bean, involves passing messages between the client and the server. SOAP, Simple Object Access Protocol, specifies how we should format requests to the server and how the server should format its responses. In theory, we could use other service invocation languages such as XML RPC or even some ad hoc XML language. However, SOAP is by far the most popular choice for web services. Transport. Finally, all these messages must be transmitted somehow between the server and the client. The protocol of choice for this part of the architecture is Hypertext Transfer Protocol, HTTP in short. The same protocol used to access conventional web pages on the internet. But once again, web services are not websites. Again, in theory, we could be able to use other protocols, but Hypertext Transfer Protocol is currently the most used one. In case you're wondering, most of the web service architecture is specified and standardized by the World Wide Web Consortium, the same organization responsible for XML, HTML, and CSS, of course. Alright, so we have just seen a simple web service invocation. At one point, a discovery service told the client where the web service is located, but how exactly are web services addressed? Now the answer is quite simple. Just like web pages, we use plain and simple URIs, Uniform Resource Identifiers, or maybe you're more familiar with the term URL, Uniform Resource Locator. But don't worry, URI and URL are practically the same thing. For example, take a look in front of you on the yellow text. The Discovery Registry might have replied with the similar URL you see right there, http webservices.mysite.com weather/us/weather service. This could easily be the address of a web page because it looks quite similar. However, remember that web services are always used by software, never by humans. If you typed a web service URI into your web browser, you would probably get an error message or some unintelligible code. Some web services will show you a nice graphical interface to the web service, but that isn't very common. When you have a web service URI, you will usually need to give that URI to a program. In fact, most of the client programs we will write will expect to receive a web service URI as a command line argument. So if you're anxious to see a real web service working, then today's your lucky day. A weather web service is probably one of the most typical examples of a simple web service. You can find a real weather web service right here on this link you see in front of you. Now, I hope you've been paying attention because that's not a web URL. So even though it may look like an actual URL, you type in a browser, you will not be able to visit it the same way. Only software that knows how to invoke web services can use this specific URI. Fortunately, the authors of that web page have been kind enough to provide a description of the web service along with a web interface, so you can actually invoke the service's methods. If you feel especially curious, you can even take a look at the web services WSDL, also available in a slightly more readable version. Enjoy!